Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing section 5.7, Negative Exponents in Scientific Notation. In this section, we will use the negative exponent rule, we will simplify exponential expressions, we will convert from scientific notation to decimal notation, we will convert from decimal notation to scientific notation, we will compute with scientific notation. The negative exponent rule. So this is a definition. And it says that if b is any real number other than 0, and n is a natural number, then b to the negative n power is equal to 1 over b to the n power. So basically what this says is if you have some real number base raised to a negative exponent, you do the reciprocal and you change the exponent to a positive number. Okay, so let's try that out and see what it looks like. Example 1. We want to simplify b to the third over b to the fifth. Okay, well what that means is that we have 3 factors of b in the numerator divided by 5 factors of b in the denominator. Well, what happens? Well, we can cancel out 3 of those and we're left with just 2 factors in the denominator, 1 over b times b, which is 1 over b squared. Well, another way we could have thought about that was b to the 3 minus 5, which is b to the negative 2. Well, b to the negative 2, the negative exponent rule says that we can use the reciprocal and write it as 1 over b to the 2 power, which is what we will do. In our final answers, we always want to have exponents be positive, not negative. Let's try another example where we write expressions with positive exponents. Example 2, we want to write each expression with a positive exponent. So for our first one, we want to do 5 to the negative 3 power. And so we can use the negative exponent rule to move this negative 3 and make it a positive by putting the whole thing in the denominator. So that becomes 1 over 5 to the third power, and 5 to the third power is 125, so our final answer is 1 over 125. Okay, let's try another. 8 to the negative 1. Well, again, we can use the negative exponent rule and change that negative to a positive by putting the whole thing, 8 to the negative 1, in our denominator as 8 to the 1 power, and we have just 1 over 8 to the 1 power, which is just 1 over 8. Okay, let's try a little more complicated example. This time we have negative 2 raised to the negative third power over 7 to the negative 2. Well, what we can do is we can move the numerator part to the denominator and make it positive, and move the denominator part to the numerator and make it positive. So let's see what that looks like. So we have negative 2 to the third power in the denominator, and 7 instead of the negative 2 power to the 2 power in the numerator. Well, 7 squared is 49. Negative 2 cubed is negative 2 times negative 2, which is 4, times negative 2, which is negative 8. So we can rewrite that as negative 49 over 8. So this leads us to a point where we can discuss negative exponents that happen both in the numerator and the denominator. Let's take a look and see what that looks like. Okay, negative exponents in numerators and denominators. This is a definition. So if b is any real number other than 0, and n is a natural number, then not only is b to the negative n equal to 1 over b to the n, we get that that is true, and that 1 over b to the negative n is equal to b to the n. Okay, let's try an example. So we want to simplify x to the negative 12 times x squared, which we can rewrite using the previous definition as x squared over x to the 12th, which we can then write as a subtraction x to the 2 minus 12, which is x to the negative 10, and we can use the negative exponent rule to rewrite that as 1 over x to the 10th, which is our final answer. Let's try another more complicated example. Example 4, we want to simplify 6x to the 4th quantity squared over x to the 11th. So we can simplify that first as 6x to the 4th times 6x to the 4th over x to the 11th. And this is just to signify and show that we're squaring both the 6 and the x to the 4th. So 6 squared gives us 36. And x to the 4th times x to the 4th, we can add those exponents and we get x to the 8th over x to the 11th. So we can rewrite that as 36x to the 8 minus 11, which is 36x to the negative 3rd. And so we can use the negative exponent rule to rewrite that as 36 over x to the 3rd power. Okay, let's try another example. Example 5, we want to simplify x to the 8th over x to the 4th, all raised to the negative 5th power. Well, what we can do is we can use the negative exponent rule and flip the x to the 4th and the x to the 8th, and rewrite that with a positive 5. Okay, and then we can distribute that inside and we get x to the 4 times 5 over x to the 8 times 5. X to the 4 times 5 is x to the 20, and x to the 8 times 5 is x to the 40th power. So we can now rewrite that as x to the 20 minus 40, which is x to the negative 20. Using the negative exponent rule one more time, we can write the reciprocal and write it as 1 over x to the 20th power. Okay, now that we've had some practice with negative exponents and negative exponents and numerators and denominators, let's move on now and talk about scientific notation. Scientific notation. Let's start with the definition. A positive number is written in scientific notation when it is expressed in the form a times 10 to the n power, where a is a number greater than or equal to 1 and less than 10, what it looks like as an inequality, and n is an integer. So you'll be asked if something is in scientific notation. Note that A has to be between 1 and 10. If it's more than 10, it's not in scientific notation. If it's less than 1, it's not in scientific notation. Okay? Let's now talk about writing things from scientific notation into decimal notation. Converting from scientific notation to decimal notation. Okay, we want to start with example 6. We want to write in decimal notation. Our first one is 3.017 times 10 to the negative 6. Okay, and the first question we want to ask ourselves is this a small number or a big number? Well, because we have a 10 to the negative 6, we're multiplying by 1 over 10 to the 6th power, so 1 over a million. So this is a really small number. So what we want to do is we want to start with 3.017, and we want to take this decimal and we want to move it to the left 6 times. So 1, 2, 3, 4, 5, 6. Put our decimal there, and we'll fill in with zeros all the additional spaces. So our answer is 0.00003017. And that's how we would write it in decimal notation. Okay, what if I had 7.4 times 10 to the 9 power? Well, 10 to the 9 is a big number, so we're going to move the decimal to the right. So we have 7.4, and we need to move that 9 times. So we move 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our decimal, and we fill in with zeros. And so we can do one more rewrite. 7, 4, 0, 0, 0, 0, 0, 0, 0, 0. We can go back and put a decimal or a comma, for every 3 zeros we have, or 3 spaces. So we have 7,400,000,000. Okay, let's try one more. What if I had $1.73 times 10 to the 9th? Well, we would do the same thing, and we would have 1.73, and we would move the decimal to the right 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in zeros there. And so we end up with 1,730,000,000. Okay, that's how you convert from scientific notation to decimal notation. Let's now move and discuss converting from decimal notation to scientific notation. Converting from decimal notation to scientific notation. Example 7. We want to write each of the following in scientific notation. We want to write the number 7,410,000,000 in scientific notation. So remember, what we want to do is we want to have no more than one number to the left of the decimal place. We want it to be between 1 and 10. So our decimal starts here, so we need to move 1, 2, 3, 4, 5, 6, 7, 8, 9. So we get 7.41 times 10, and it's going to be either 9 or negative 9. Why is it going to be a positive 9? Well, it's positive 9 because 7 billion is a really big number. So we're multiplying by 1 billion. Okay? So for part B, we have 0.000000092. 2, not 9. So again, we want to move the decimal in such a way as there is one digit to the left of the decimal. So in this case, it's a small number and we'll need to move to the right. So we'll move 1, 2, 3, 4, 5, 6, 7, 8 times. So we have 9.2 times 10, and in this case we'll have a negative exponent, negative 8. What if we wanted to do computations with numbers that are in scientific notation? Computations with numbers in scientific notation. So for multiplication, imagine that we're going to multiply two numbers in scientific notation. So a times 10 to the n times b times 10 to the m. Well, that's just a times b times 10 to the n plus m. Now be very careful when you're multiplying that this a times b is not greater than 10, because if it's greater than 10, you'll have to change the power of 10 here and move the decimal for this number. Okay, for division, we have a times 10 to the n divided by b times 10 to the m. Well, that's just a divided by b times 10 to the n minus m. And then finally, exponentiation. If you have a times 10 to the n raised to the m power, you just distribute that exponent inside to the a, so you get a to the m and 10 to the n times m. So that's how we do computations with numbers in scientific notation. Let's now try a couple of examples. For example 8, we want to perform the indicated computations and write the answer in scientific notation. For part A, we have 3 times 10 to the 8 power times 4 times 10 to the 2 power. So we take the numbers to the left of the multiplications, so 3 times 4, and then we multiply that by 10 to the 8 plus 2. Well, 3 times 4 is 12 times 10 to the 10 power. Well, notice that our number is greater than 10, so our decimal is here. We need to move it one place this way and add 1 to our 10 factors there. So it's 1.2 times 10 to the 10 times 10, which is 1.2 times 10 to the 11th power. Okay, let's try another. 8.4 times 10 to the 7th divided by 4 times 10 to the negative 4. Well, that's equal to 8.4 divided by 4 times 10 to the 7th divided by 10 to the negative 4th. Well, 8.4 divided by 4 is 2.1 times 10 to the 7 minus a negative 4. And 7 minus a negative 4 is the same as 7 plus 4. And 7 plus 4 is 11. So our final answer there is 2.1 times 10 to the 11th. Let's try one more. This time we have 4 times 10 to the negative 2 power, that quantity raised to the 3rd power. So what we do is we raise both the number and the 10 to our 3rd power. So it's 4 to the 3rd power times 10 to the negative 2 power raised to the 3rd power. And that just means that we multiply those exponents together. 4 to the 3rd power is 64 times 10 to the negative 6 power. And notice again that in this case, 64 is greater than 10. So we need to move the decimal over one place to have 6.4 times 10 to the negative 6 times 10, which is 6.4 times 10 to the negative 6 plus 1, which is 10 to the negative 5 power. So that is our final answer. Let's try and apply. Example 9. In 2014, a 2-story home in Spring, Texas was overtaken by bees. The bee removal expert stated that there were over 500,000 bees living in the house. Write this bee population in scientific notation. So again, remember, we want to start with our number, with our decimal there, and we want to move the decimal where there is one digit to the left of the decimal. So we'll move the decimal 1, 2, 3, 4, 5 times. So that's 5.0 times 10 to the 5. And why is it positive? Well, 10 to the 5 is 100,000. It's a big number, and 500,000 is a big number, so we expect that our exponent should be positive. Be on the lookout for questions like this to show up in your homework and on exams. That is the conclusion of this section. That's section 5.7, negative exponents in scientific notation. Good luck on your homework. Please let me know if you have any questions, and I will see you in the next one.